Hey guys, welcome back. So today I've got something a little bit different. This is a 36,000 watt Generac generator, and it actually doesn't belong to me. It belongs to Rob, who's standing right next to me. Say hello, Rob.
Hello.
Anyway, he got a heck of a deal on this. Brand new, they sell for about $13,000. I think he paid about $200, and that's for good reason. It doesn't make power. That said, there's plenty of room here to put some money into this and get this working again. Now, he has done some testing on it. He believes the Stator is bad, and of course the Stator is still available. They sell for about $2,000 up to $3,000 depending upon where you look. And in this case it might be worth it. So Rob wants a second opinion, so I'm gonna take a look. Let me get you set up a little bit better and get going on this. So there's not too much to test down here. I mean, we have the brushes, there's actually two sets, and the slip ring. So we can check the rotor from here. As far as the Stator goes, all the wires actually go up into this electrical panel here, and they terminate right here. Now, there are a lot of broken, or I shouldn't say broken, a lot of cut wires. So the fact that he had this running and it wasn't making power isn't necessarily a bad Stator, but this was sold to him as a generator that doesn't make power, and when he fired it up, the engine sounded good, but it did not make any power. So I tend to believe that we do have bigger issues down there with the Stator. In powering this generator, it is a 4-cylinder Mitsubishi engine, which I find a little surprising. I thought Generac made their own engines on stuff like this. Anyway, it is electric start. This one is propane powered, and this is also liquid cooled. And I was kind of surprised to find a turbo sitting way over there in the corner. So it's a decent engine. He has had it running, so that is not the issue. We need to take a closer look at this. So we'll check the rotor first. That most likely is good. Good rotor should test at about 8.1 ohms. And we're at 7.5, so that seems to be good. We'll check it to ground. And there's a connection to ground at 76 ohms. So most likely the rotor is bad. And as far as the Stator goes, these are the main windings coming out here. We have leg 1, I believe are these two wires, and leg 2. A healthy Stator on this should come in at about 0.4 ohms. And that's pretty much a dead short. It's the same as connecting these together. So the Stator would seem to be bad, but let's just check leg 2. That's about the same. Let's check them to ground. So just cleaned off a spot here. We're going to check leg 1 to ground. Ideally, there should be no connection. But we do have a connection. It's about 400,000 ohms. All right, let's check leg 2. And a little bit higher, about 500,000 ohms. Unfortunately, the damage to the power head is much more severe than both Rob and I thought. We had assumed that yeah, the stator would probably be bad, but the rotor kind of surprised me. So this generator needs a new stator and a rotor, which doesn't leave a whole lot of meat left on the bone. I mean, this generator in used condition would probably sell for about $6,000. You know, a new stator is $3,000. A new rotor, I actually haven't priced out, but I'm willing to bet it's close to the cost of that stator. So, you know, all in, best case scenario, I think we'd break even getting this thing fixed. So do a bit of research. Potentially that rotor doesn't cost as much as I think it does, and potentially there'll be a part 2. Anyway, since I'm here, Rob does have some rusty old junk, including a Kohler generator that was made probably in the early 50s, and he has another antique engine as well. So we're going to fire those up and just show you how those work.
Okay, so this is a Myrick Eclipse engine. It's an oil field engine from probably the late teens, early 20s. I would work on an oil well, either pumping oil or pumping water off the top of the oil well. It's fueled by, it would have been fueled by natural gas because that was a byproduct of the oil drilling process. Now we run it on a barbecue tank. It's a hot tube engine, so we're going to start a burner and it's going to heat a stainless steel tube here to a red hot. When the combustion gas gets pushed up into that tube by the compression and hits that red hot point, it'll ignite. Takes a few minutes for it to warm up, but we'll get it lit here. So that'll take about 10 minutes to get hot, and then we can start it.
Where'd you find this?
A friend of mine collects them. This was a little one for him. He has a bunch of massive oil field engines, basically the size of a small car. He's got, I think, 4 or 5 of them at his house, and he had 3 of these that he came across, and I really liked it, so he gave me one. It was all in parts. We had to put it together.
Okay, that's my next question. So it wasn't in running condition. It was something that...
It was... This one is bits and pieces of Myrick engines. I think this part is the original. The head is not the original. The hot tube is from another engine. The plumbing, of course, is all stuff that I did. I had to build an exhaust valve for it because that was in pretty bad shape. But it's a conglomeration of different Myrick engines. It's not original. It's probably not very valuable, but it's fun.
It's a nice showpiece, though. It's interesting, the head cooling. Just
yeah, it's air cooled.
Yeah.
This is a clutch that would have been belted to a pump jack.
Okay.
There would have been a big lever here that you engage a clutch with, and it would they would run for years with very little maintenance. We might have trouble because it's a little bit windy, but so this one was built in, all the Myricks were built in Olean, New York, which is a couple hours north. And then this one worked in a oil field somewhere in Pennsylvania. And made its way back here. Oh, backfire a little. Once it warms up, it'll run a little bit better.
What else do you have to do? Replace the hot tube?
The hot tubes will burn out occasionally, or eventually. You know, they probably have to put new rings in them from time to time. But really, you know,
not a lot of parts to service.
no, and you know, you'd have one guy that would come around a couple times a day and oil everything up, and they would literally run them for years, almost non-stop. Because when they stopped, they weren't making any money. It's a round belt from McMaster. I couldn't find one. I couldn't find a black one. Or originally it would have been a leather belt.
Yeah.
Can't really find them anymore. I'm sure you could if you look, but it'll put along like that all day. Sure. I have it sitting out here because I want the plumbing to rust up a little bit.
Yeah.
And,
All right, so this one's a little bit more up my alley. This is a 4-cylinder, I believe gas-powered generator. It is a Kohler, made most likely in the late 40s or early 50s. And Rob actually uses this one to power his house. So we're going to fire it up, probably hook up the multimeter and just see what we're getting.
Sure.
I actually did not bring the kilowatts, so we'll be able to check the voltage, but not the hertz, sadly. So let's fire this thing up and see how it sounds.
Well, this one's a little bit simpler to start up.
Wow. Very nice. Very nice. Got a little electric start there. Very cool.
These were actually very popular in marine applications. They would have cooled them with seawater and in the bottom of a boat somewhere.
Oh yeah.
There's not a lot of them that are set up for home use, but there's still quite a few of them around in marine applications. In fact, there's a couple places in Florida where I buy parts that are primarily marine dealers.
All right, not too bad. 117 volts, 61.5 hertz. It's perfect. Not a bad setup. I mean, this thing, for 5,000 watts, 4 cylinders, that is not something you will see today. Anyway, I am interested in what's in here. So we're going to pull this cover off and just take a look at the electronics inside.
Sure what we're going to find in here.
Hopefully not a mouse.
Oh, looks pretty clean.
A little bit different inside from modern generators. So I don't know exactly how all this stuff is tied in. There is actually a circuit diagram here, but it is a bit hard to read. But from what I can see, I mean, obviously we have a transformer here. This looks to be a bridge rectifier. We got 4 wires going into it and an adjustable resistor right there, most likely for adjusting the power output, and another resistor here on the outside. The rest of it is just a few contactors, a starter solenoid, and looks like some connections to the charging system. But, overall, fairly straightforward design. This engine is built very well. You would not see something like this made today for a 5,000 watt generator. So that's pretty much it. Maybe not the happy ending everyone was hoping for, but we did get to see some cool toys, and who knows, maybe there'll be a part 2. Hope this video helps someone. Thanks for watching. Not so fast. I made a rookie mistake here. I left the brushes connected to that rotor, and the wire going into the control panel I thought was disconnected, and whether it was or not almost doesn't matter, because this wire right here connects over to the brushes, and that is why I got a connection to ground of 76 ohms. Thankfully, Rob uninstalled the stator and the rotor and ran another test. Let me show you. So here Rob is testing between the slip rings. Ideally it should be 8.1 ohms, and he's getting just about that. It is temperature related, and it is a cold day, so 7.8, 7.9 should be fine. And now he's checking the slip ring to ground. And this is a low voltage test. There is no connection, and according to Generac, that is good. Now he is using a high voltage test at 500 volts between one of the slip rings and ground, and there is a connection. It's close to 60 million ohms. I'd like to see that higher, but I think this rotor is good. So Rob has placed an order for a new stator, and potentially there'll be a part 2. Let's hope.